Alright, so for my final project I created a program called MIDI Hero. So what this program is it's an educational music program. It's designed to indicate to a player whether or not they're playing the right notes by reading in MIDI input signals. In this case, from a Teensy microcontroller, I uploaded some test code to my Teensy to play the songs that I have in the game right now. And it's going to show you what measure you're playing and if you're playing the notes correctly or not. So we can go ahead and see an example of that real quick. All I have to do is unshort one wire on my Teensy, and it'll start sending the MIDI signals. So we can hear the notes generated through her playing. We can see the measure tracker is following along, telling us we're doing a good job. We're not missing anything.
Well done!
And there's the end of note indicator right there. So you probably want to see some wrong notes being played too, so I'll show you that. As soon as it starts up again, it'll take a few seconds. And to play a wrong note, all I have to do is short this pin. And it'll say try again, because we're playing the wrong note. But it continues along and picks back up in the song right where we left off. But we still made it to the end of the song, so we're still congratulated. Okay, so if we want to load the next song here, I can just put a plug in this guy to stop playing the songs, and all we have to do is, as we see the controls in the top left, we hit R to reset song. So if I resume this song real quick, we'll get a little ways down the road. I'll pause it. If I hit R to reset the song, and I start playing again, if I hit R, it starts back at the beginning, but now since my microcontroller and the game are out of sync, it's going to be saying, yeah, we're playing the wrong notes. So I'll put that on pause again, and I can go ahead and hit 2 to load the other sheet music. So this one, just as iconic and wholesome of a song as Amazing Grace, we have next our meme mashup. This song starts off with All Star, plays a little Never Gonna Give You Up, some epic sax guy, and ends with Sandstorm. Admittedly, the Sandstorm plays too slowly, but you can get the idea. I didn't feel like putting custom tempos in for every song, or every part of this song, rather. So all I have to do to start this is short the other pin on my Arduino, my Teensy, rather. And here we go. Again pops up. And there's a repeat right here. And the measure tracker goes back. Sandstorm needs to be a lot faster.
Well done!
Alright, and we got our well done indicator there. That's actually a sound clip from Donkey Kong 64. I was playing some of that over spring break, so I thought it would be fun to include. And it makes the player feel good about themselves. They did a good job. They got the song done. So that's pretty much the game here. At any point, we can hit 1 and go back to Amazing Grace, hit 2, go back to meme mashup, and that just sets the song from the beginning, or you can hit R to reset this song. So that all works as intended. Now I'll go into a little bit of the code and demonstrate a bit how some of the stuff works. Starting off with the MIDI input, I'm using the rtmidi library right here. The GitHub link will be included in the description to where you can find that. So then in the glview new module implementation file, the MIDI code is in load map is where the first MIDI code is. So if we go to load map here, we can scroll down here and see where we set up the MIDI input. Some of this code is borrowed from the example file included with the rtmidi library called cmidin.cpp. So if you want to find it there, you can. This stuff here, for example, we do this and set up our MIDI port. The part that I customized to make work with my song and give me the data from the MIDI messages that I need is this set callback function. So we can go ahead and find that now. Oops. My callback function is the name. All right, so yeah, in my callback, basically all I'm doing is the same way the sample code did. I'm stepping through the MIDI bytes, but I added to where I'm checking for if it's a note on or if it's a note off message. I'm setting my note off received, note on received, so I can have that information, as well as setting the note played. So once I get that information, we're just going to go ahead and jump over to the update world. So in the update world function, we're using the information that we just pulled from the MIDI bytes, and we're saying if we received a note on, then we're going to go ahead and we're going to set up the sound and play the note sound right here. And if we have the, we're also going to, as a part of my sheet music class, which I'll get into in a minute, we're going to be checking the current note of our current song, and we're going to be testing note played against the current note that is saved in the sheet music. All right, so then after that, if we receive a note off, then we're going to reset. I didn't mention up here, but yeah, we're resetting the note on received and note off received back to false so that they don't continue to look as if they're triggered. So then we're just going to go ahead and, as part of our sheet music class, check if we're at the end of the song. If we are, we applaud, we play well done, and we update our measure tracker. All right, so I'll just go real quick to update measure tracker, and all this does is it checks the song name that we're playing. If we're playing Amazing Grace, then it updates the Amazing Grace. That's what AG is, and if it's meme mashup, then it's MM right here. So we update the measure tracker red and blue with the current we have a get measure tracker function as a part of our get measure tracker X, get measure tracker Y as part of our sheet music class, so we can get those pieces of data to set the new position based on the current measure that we're in, and then we set it either in front or behind the page of sheet music so we can see it or have it hidden based on if we're playing the right note or not. Then I think the next thing I should show you is if we go to the load Amazing Grace here. So this is on a key press, as we can see here. It's also the default sheet music. If you want to, you can uncomment this to make the load meme mashup be the default sheet music. That's something you can do. But yeah, by default, we're loading Amazing Grace. And what this does is, first we set the camera position to be above the sheet music, and then we set the camera look direction to look down on the sheet music. There's a problem with this where if you don't first move the camera when you launch the game to look a little bit more towards the sheet music, it breaks the camera and the screen goes black. It's not even a thing where the camera's looking the exact opposite direction, because it's not. But it's just looking off to the side and can't see the sheet music. Once you move the camera a little bit, angle it down, and then you press 1 to load Amazing Grace, then this works just fine. I'm not completely sure what that is. It's, the camera functions aren't a part of my code themselves. So, but with that small workaround, it worked pretty well, and I felt like it's a minor enough bug. So anyway, what we do here is we set we set up an array of integers with all of the note values. Now that's how MIDI does the notes is like, for example, middle C, I believe, is 60, and everything else is one higher or lower from there as you step up in half steps. So then we create, set current song to a new sheet music with this array as notes, and then the length of 35. And then we also have the measure list, and we set the measures right here. So this is basically every note. The first note is of measure 0, the second note is of measure 1, and so on. That lets us, when we go ahead and get the measure tracker information, it lets us know what measure we're looking at, so that we get the correct coordinates. So then we set the measures here, like I said, with these values. And we also do the same thing. We create arrays for the Amazing Grace X coordinates and Y coordinates, and we set those through the set measure tracker X, set measure tracker Y functions in the sheet music. All right, so that's everything in this. If I go ahead and go to the sheet music class, we can look at that. The sheet music class has everything that it needs here, the functions of it. So when we create it, we pass, like we saw, an array of integers as well as the integer of length. Check current note, we return true if it is the current note, and we also increment the current note, and we update the current measure as well with this current measure function, and we set the current measure equal to the array measures that we put in when we said set measures, and we update the current measure with the current note value of measure. So this will just be incrementing. This is the iterator for the array. So then check end of song, we just see if the current note is equal to the length that we saved when we started, when we first created the sheet music. If so, song's completed, and we reset the song. So in reset, we just set the current note, current measure to 0, and then that's where in the main code, if we return true if we return the true here, then we play the well done and the applause. So then here's your set measures. These are all really basic. We just check what the current measure is. The current. So then this just calls the current measure function. Yep. To determine what measure tracker coordinate we need, and then this is just a step measure trackers function that works the same way as all the other array creation functions. All right, so that is everything. Some complications I had was I initially didn't know. I additionally didn't know that in this file we needed to, to run rtmidi. I initially didn't know that we needed to include. Here, I'll go ahead and show you in properties. Oops, it's in the other screen. Okay. So I initially didn't know that we needed this. The Windows multimedia added as an additional dependency. So I'm trying to find which one that was in. Additional dependencies, here we are. So as we can see here, this is what you need to do if you want to run this. Oh, it's in the other window. I couldn't see it. Okay. Windows Multimedia Library, that's what we needed to include. So you put that there. And in preprocessor, as your preprocessor definition, you're going to want to put, oh, the other window again. you're going to want to put Windows MM for multimedia. So that's what you need to do to use the rtmidi class with Windows, and it works pretty great. I ran into some other issues where I hadn't named the notes correctly, so my songs all sounded terrible. That was not very fun, because if you look here in my multimedia folder, there's going to be sounds, and I had to custom create all of these sounds because I thought there would be a convenient repository of all of the notes from a piano being played, and I could just download that. But I couldn't find anything. So I opened up FL Studio and just played the notes one at a time and recorded them in OBS Studio, and then exported that, and then stripped the audio from it using a converter, and then got that to a WAV file, and then I put that in Audacity and trimmed it note by note by note. And of course I got some of them wrong, so all the notes were wrong, and it sounded just atrocious. But now it sounds good. So yeah, that's pretty much everything. I guess I can show you the MIDI test code right here, or written for the Teensy microcontroller. So if you go ahead and upload this to any Teensy, it should work. Some things you need to know is if you first off install the Arduino IDE. Secondly, if you do have a Teensy, you're going to want to go ahead and select the Teensy you have. Any of these would work. You just need to set the right one. Mine's a Teensy 3.2. Then in USB type, you're going to want to go ahead and hit MIDI or Serial plus MIDI. I was previously using Serial for debugging, as is common with Arduino, but I don't really need that anymore. But anyway, how this code works, it's got a bit of a description at the top here. So it tells you to test the meme mashup code or meme mashup song. All you have to do is connect a wire from ground to digital pin D0, and then to test Amazing Grace, you disconnect that wire. And then to test playing an incorrect note, you connect a wire from ground to D1. And then to restart a song from the beginning, you can just disconnect and reconnect the ground wire to D0. So that way it switches songs, switches back, and it's reset. I did add one other pin in here just for recording this video that's not up on the GitHub repository currently, which will be linked also in the description. And that is this right here. It's just, I put a pause pin on digital pin 2. So if you connect pin 2 to ground, it'll just stop playing anything. But yeah, basically all this does is it has the same array of notes right here, but it also, something new that the game engine doesn't care about is these note durations are here. And the note durations just set at what interval we're sending MIDI on messages. And we just step through the arrays. We just step through one array versus the other based on if the pin is grounded or not. And this pin was previously just tells if we were previously playing a different song and now we're playing this song, we need to reset our I and J counters back to 0 to the beginning. Yep. All right, and that's everything. I had a lot of headaches, but a lot of fun making this. So I hope you liked it. I guess I can leave you on a song if we'd like. Here, I can go ahead and build this again. It'll be my outro music here. So this is what I was saying. You have to move the camera, then you hit 1. All right, now we're set. And we can just go ahead and disconnect 1. I'll leave this connected, and I'm going to go ahead and hit 2, and we're going to play the meme mashup. You might be on the end of a loop here. Curious. Okay, so this is, I suppose this is error number 2. If no, we're good. All right. Well, that's an Arduino bug. That's not a game engine bug. on that note, literally, yeah, have a good one. That's all I have.